Hi, today we'll take a look at how to use the ultrasonic sensor with ESP32. We'll demonstrate how to use the MQTT library to send data over Wi-Fi to your local network, local broker. And the whole idea behind it is we want to detect height changes, and if there's any height changes detected, then uh, we will send that data over to the MQTT broker. Okay, so the first thing that you want to do is go ahead and either download or clone the repo for the IoT Simplified repo, um, and then go ahead and open it up with your favorite IDE. I use Visual Studio Code. You could use anything that opens text really and edits text. So you want to go ahead and go into the folder, the O2 ESP ultrasonic sensor or detection, sorry. And then when you're here, you want to go ahead and also go to ESP IDF. So you want to do a menu config, and that should build it up real quick. Okay, cool. So it's built. So you want to go to example configuration because that's where we have our configuration settings. Okay, after that's all done, go ahead and select save. Okay, exit, and then exit again, and exit one more time. Okay, before we go any further, we want to just go ahead and take a look at how to set up the actual sensor. So as you can see, we have four wires that'll come out, so you can plug them in however way you'd like. I just used extension wires, such as the ones shown in the demo video here. I connected it in a way where they're just basically on top on on a box cover there, and uh, the pinouts of them is each one of them would basically have your VCC, um, and then voltage, and then trig, and then your echo, and then your ground. So the first one we'll go ahead and plug in is the ground. So that will be uh, this pin right here. So we'll go through real quick and plug in all the pins into the right numbers there. I plugged in the actual echo out and trig into each one is goes into 23. One of them is 23 and the other one is 22. I'll post more information about which inputs are where on the actual description there. So yeah, that's how you plug it in, and then after that you want to go ahead and connect it using USB into your PC and should be set up and ready to go. Okay, after saving and completing the configuration, what you want to go ahead and do is uh, flash the program. So you use your port number here, COM4 in our case, but yours is going to be different communication number, and you can find that always by going to Device Manager, and under Device Manager you go to Ports, and that's where mine is COM4. Okay, and then you want to go ahead and flash and monitor. So the way that this will run is it'll first flash it and then we'll run the monitor command afterwards. And the monitor command is just to show the serial output of the device. Program. So as you can see now, it's going to go ahead and show you the distance in inches and the person height, which is currently 0 because there's nothing blocking it. And then the pulse width of the returning signal timings, right, between how long it took between each. So Okay, and this is an image that I found on Google from circuitstoday.com, and basically shows perfect example of how this works. Is we first send a trigger to the ultrasonic sensor, and then the transmitter would output eight 40,000 hertz pulses, and then it would wait to hear from them back, and then it would send out an echo output that the width of that output, how long the high was, like how long the signal has been high for, that would give you the pulse width, and that basically tells you the distance. So it's proportional to the distance of how long it took for it to come back, the signal for it to come back, and it just hits any surface or anything like that. And that's the working principle. So now it is sending. So it's not sending any data right now. It only sends data when it detects there's a change in the distance, and so at a change that's greater than or 2 or greater than 2. So let's go ahead and run the Python uh, code here that will basically process the data for us and save the data in the sensor data.csv. So make sure that you have that folder in the directory here, sensor underscore data.csv, because that's what the Python script here will use to run it. So you can run this Python script using really any of your platforms that you use. I like to use the one already integrated in Visual Studio Code. I just have to run it. And then we would be able to see a live data over time with a graph that was shown um, uh, from the Python here. So I'll go ahead and go and make some movement here on the sensor here, and then you'll see how it's going to go ahead and start graphing. So put my hand across it, and then that gives you kind of my hand out there. And then when I let go, it'll go ahead and graph back where it originally started, which is back to 0 here, as you can see. The graph going back to 0. So I put my hand here, went up to 7 inches, and then back down. Then I put my hand again over here, and that went up to 8 inches again. So if I want to go ahead and put my hand one more time, so a little bit higher this time, so go ahead and bring it up a little bit higher there. And there you go. So it goes up to a little bit further there. So it goes up to about 170 inches, I believe, the maximum height that it would reach. Um, but yeah, that's how you're able to achieve that part uh, uh, of the program here. Okay, so let's talk about a real quick application here that you could actually start running and using at home. I'm just using your little whiteboard here to draw this idea. So what you could do is, or at home or an office building or really anywhere, you could use it by a door. So imagine that this is a door here, and you could put the sensor on the top right here, and that's where it would kind of configure itself. So for the first about, I want to say 60 to 70 milliseconds, it will go ahead and calibrate the sensor. So meaning it'll catch the first measurement, which say, from here to here, say it is about, I don't know, say it's, I don't like say this is a small door, so it's 8 inches, right? Um, so it's from the top of the door or from the top of the sensor all the way to the bottom is about 8 inches. Say a person that walks by here. Now it's configured for 8 inches, right? So it's calibrated at 8 inches. Say a person walks through. Um, Now let's go ahead and draw with a different color how that's going to go ahead and go. And then when it sends out a signal and it reads off top of that person, then it'll go ahead and uh, deduct or minus it out or subtract it out from the overall height, and it will be able to achieve what's the height of this person, right? So by getting this, say this is 4 inches, and so therefore the person's height would be 4 inches. So your output would be 4 inches. And that's one way of using it here, just for you to either keep track of people coming in and out of a building, or you could also see what your house, as for security. Obviously your height's not going to change that often. You could even use it at a, say, gas station to make sure that you're keeping track of people's height as they go in and out. That's pretty important if they commit a crime or anything like that. But yeah, that's one application that you could use it for.